Hi everyone, welcome to my channel. This is another video of graph series. In this video, we will learn about DFS. In the previous video, we learned about what is BFS, code of BFS with dry run. So in this video, we will learn DFS in the same manner. So without wasting time, let's get started with the brand new topic, that is DFS. So before starting implementation, code and dry run, let's walk through this definition and statement about DFS. Firstly, I will tell you the full form of DFS. That is depth first search. Depth first search means basically go as deep as you can go before backtracking, before coming back. Okay. That means if we will start from this, so we need to go as deep as you can. We can go through this node. So this is the last node which has no any child. So we need to backtrack from here. So the simple definition of DFS is DFS means go as deep as you can before backtracking. So this is the simple point about DFS. Don't focus on theory, focus on logic, implementation, code and dry run. This is very important. So other important points about DFS is that it uses recursion or stack, it follow backtracking, it works on both graph and tree, and this is the very important thing. What is the time complexity of DFS? This is very important thing. Interview will definitely ask you about the time complexity of DFS. So the time complexity of DFS is order of V plus E. V is vertices and E is edges. So now coming to the main thing, this algorithm. So I will simply explain you all this algorithm. So firstly, we need to create an visited array, okay, and we need to mark all node as unvisited and start from the given node. Suppose the given node is 1, so we will start from here and mark it as visited. We will mark it as visited and we will print the current node. That means we will print this node. Now we will traverse all its neighbor 2, 5 and 9 and check whether these nodes are visited or not. If these nodes are not visited, then we will call DFS for this node, and again we will check neighbor of this node, visited or not visited. So we will call DFS for this node. Again we will check neighbor, visited, not visited, call DFS for this node. So this is the simple algorithm of DFS, that mark visited, check neighbor, if neighbor is visited then print it, otherwise we need to call DFS for that particular neighbor node. Okay, so this is the simple algorithm of DFS. So coming back to this, the thing that is very important is this pseudocode. We will follow this pseudocode to for the dry run of this particular example. Okay, so let's understand what this pseudocode is. So pseudocode and this algorithm is basically same. So this is kind of code that is you know, this is kind of 50 to 60% of code. So let's understand this. Suppose we need to call DFS for this particular node 1. We will mark it as visited, mark this node as visited and print this node. We will simply, let me print it out. Okay, let me print it out. Now we will check the neighbor of this node. That means DFS of 1 is completed. Now we need to check neighbor. Neighbor is 2, 5 and 9. So we need to check DFS of 2, 5 and 9. So what is the DFS of 2? When we come to DFS of 2, then we will also follow all the this step. So coming to DFS of 2, suppose DFS of 2, we will mark it as visited, and we will simply, let me print it out. Okay, now what is the neighbor of this 2? 3. So we need to call DFS of 3. Again, call DFS of 3. Mark it as visited. Print this node. And check the neighbor. Neighbor is 4. 4 is unvisited. So simply we need to call DFS of 4. Mark it as visited. Okay. So DFS of 4. Mark it as visited. Print this node. And check the neighbor. Is there any kind of neighbor of 4? No, there isn't any kind of neighbor of 4. So we need to backtrack from here. So we'll backtrack. We'll go here. And again we check the neighbor of 2. 2 is visited. 3 is visited. 4 is visited, which is the neighbor of 3. 3 is the neighbor of 2. And 2 is the neighbor of 1. Now check for 5. 5 is unvisited. Okay. So we need to call DFS of 5. DFS of 5. Mark this node as visited. Simply we will mark it as visited. Print it out. Let me print it out. Okay. Now, what is the neighbor of 5? 6 and 8. So firstly we will call the DFS of 6. Mark 6 as visited and print it out. So what is the neighbor of 6? The neighbor of 6 is 7. So we will simply mark it as visited and print it out. Okay. So is there any kind of neighbor of 7? No, there isn't any kind of neighbor of 7. So we need to backtrack from here. So we will backtrack. We will go to 5. 5 is the parent node of this node. So we will go here. We will check that neighbor of 5 is 6 and 8. 6 is visited, 7 is visited, which is the neighbor of 6. So another neighbor of 5 is 8, which is unvisited. So what we will do, we will mark it as visited and simply print it over here. So now, is there any kind of neighbor of 8? No, there isn't any kind of neighbor of 8. So we need to backtrack from here. We will go to 5. Is there any kind of neighbor of 5 that is unvisited? No. All the nodes, all the neighbor of 5 is visited. So we will go to 1. Check whether nodes are neighbor of 1 is visited or not. 2 is visited, 5 is visited, but 9 is unvisited. So we will go towards 9. Now we will call DFS of 9. So when we will call DFS of 9, we will mark 9 as visited and print it here. Sorry, 9. Now, is there any kind of neighbor of 9? Yes, 10 is the neighbor of 9. So we will call DFS of 10. So when we call DFS of 10, we will mark it as visited and print it out simply. Okay. So this is the order of DFS traversal. That is, this is the order of DFS traversal of this graph. Okay. Let me conclude all this scenario, and after that we will move towards the code. for DFS of 1, firstly we will mark it as visited and print it. Now we will check the neighbor of 1, that is 2, 5 and 9. Now we will call DFS of 2 firstly. So for DFS of 2, we will mark it as visited and print it out. Now we will check the neighbor of 2. Neighbor of 2 is 3. So we will simply mark it as visited and print it out. And after that we will check the neighbor of 3. Neighbor of 3 is 4. Simply we will mark it as visited and print it out. Is there any kind of neighbor of 4? No, there isn't any kind of neighbor of 4. So we will backtrack. We will go towards 3. Is there any kind of neighbor of 3 that is unvisited? No. So we will go towards 2. Is there any kind of neighbor that is unvisited of 2? No, there isn't any kind of. So we will backtrack and go towards 1. So now here, is there any kind of neighbor of 1 that is unvisited? Yes, 5 and 9. So we will simply go towards 5 and call DFS of 5. So DFS of 5, when we call DFS of 5, then we will simply mark 5 as visited and print it out here. Now when we call DFS of 5, we will mark it as visited and print it. Then it has neighbor 6 and 8. We will call DFS of 6 firstly and mark it as visited and print it out. So we will simply print it. So now after that we will call DFS of 6, mark it as visited and call its check its neighbor. Its neighbor is 7, which is unvisited. So we will call DFS of 7. We will mark it as visited and print it over here. Is there any kind of neighbor of 7? No, there isn't any kind of neighbor of 7. So we will backtrack, go towards 6. Is there any kind of neighbor of 6 that is unvisited? No. So we will backtrack and go towards 5. So is there any kind of neighbor of 5 that is unvisited? Yes, 8 is unvisited. So we will go towards 8 and mark call the function DFS of 8, mark it as visited, print it out and check whether is there any kind of neighbor of it. No, there isn't any kind of neighbor of it. So we will go towards 5. Backtrack and go towards 5. Now we will check, is there any kind of neighbor of 5 that is unvisited? No. So we will backtrack and go towards 1 and check whether is there any kind of neighbor of 1 that is unvisited? Yes, 9. So we will go towards 9 and call DFS of 9 for it. For this, mark 9 as visited and print it here. Now we will check, is there any kind of neighbor of 9? Yes, 10 is the neighbor of 9. So we will call DFS of 10 function for this. We will mark it as visited and print it over here. So check whether any kind of neighbor of 10. No, there isn't any kind of neighbor of 10. We will go towards we will backtrack and go towards 9. Is there any kind of neighbor of 9 that is unvisited? No, there isn't any kind of neighbor of 9 that is unvisited. So we will backtrack and go towards 1 and check whether there is any kind of neighbor of 1 that is unvisited. No. So the overall traversal is complete and we got this order of traversal. So this is what DFS is. You will get all this all example and dry run step by step, this theory, this pseudocode, this key points and this algorithm on my website once it got live. Currently it is under development, so once it live I will inform you. Now let's come to the main part, that is implementation of code, how you can write the code for DFS. So let me come to VS Code. Here this is the simple boilerplate where we take and nodes and edges as an input, and this is the graph, and we will take input as edges as input and push it in the graph. And here we have created a visited array, and I will tell you the use of this visited array. Okay, so now we need to implement this DFS function. We will make it void, so we will write void DFS. We will take a starting node here as a parameter, and we will create a vector of vector same as, okay, we will take a visited array as a parameter of type bool. Okay, so this is the simple form of our DFS function. Now we will mark the starting node as visited. Will true. This visited array will keep track of whether the node is visited or not. Okay, so we will simply print this node. Okay, now we will check the neighbor of this node. Okay, if the neighbor is not visited, then we will call DFS for that particular neighbor node. That's all. This is the function of DFS. Now in the main function we will let me write DFS Traversal. DFS Traversal. Okay, we will call this function DFS of 0. We will start from the node 0, give input as ADJ, that is our adjacency list, and visited array. Okay, now that's all. Let's check whether it gives the correct output or not. Control-Shift backtrack. Let me save it first. Okay, G++ YT tag. Okay, oh sorry, Control-C. Wait. Okay, now take number of nodes and edges as 5 and 4, 0, 1, and 0, 2, 1, 3, 2, 4. This is the order of DFS traversal. So that's all for today, guys. Hope you enjoyed this video. If you enjoyed, please like and subscribe. We will start the lead code problems in the next video. So till then, bye bye.